So this is the field test for the NFC data exfiltration using a USB dongle. I just connected to an old laptop that I had around. Some of you might recognize it. So I'm just going to start the receiver, start listening. The payload is our famous secret password, and you can see that we are getting some data now. So a small error over there after the C, and basically I'm going to start walking, and let's speed it up and see how far can we get and still have a signal. I have the measuring tape over here. It's 30 meters, so let's go. So at 20 meters we have a pretty nice reception, and it's decoding. There's some minor errors here, but they're mostly being corrected. And yeah, the transmitter and the receiver, they need some work. Let's continue walking. So right now we are at 30 meters. 30. Let me just start the receiver again. Stop. And start. So we see that we still have signal, and we still have some proper data decoding. Right now it's password, and I am at the end of my measuring tape, which is 30 meters. So let's just continue and see how far can we go and still get some meaningful data here. Actually, I can also unplug the audio jack so we can listen. Yeah, it's pretty audible, right? We can still listen. Let me plug it in again so that the software can try and decode the signal. Yeah, you can see it's there. Password again. This was just pure luck. But yeah, now the signal was lost for a bit. I had to put it a bit louder so the software can catch it better. Okay. Secret password. I actually I don't know how far we are. It's like the laptop is over there. This is the measuring tape. We are, I don't know, 40 meters something. Let's just walk more and see if we can still have some signaling. Okay. You can see it, the signal strength. You can still detect something, and we can still, yeah, we are still getting data. Okay, this is okay, secret password. So I don't know how far I am. I'm just going to continue walking until I don't have a signal anymore, and then try to go to maybe measure it or see it on Google Maps and figuring out the distance. We can see there's some errors now, but we still have a signal and we are still decoding it. Yeah, secret with the tree. That's not an error. There's an error there. But this is okay. Now it lost the signal. It's trying to acquire it again. We have some trees on the way also, which does not. Let me try and put it on a straight line of sight. Okay, now we are not getting the signal anymore, but this is. So I also took out my radio scanner, which has LSB decoding, and you can hear the NFC signal a bit better. Let's try and see if you can hear it here. I hope you can hear the little beeps. And well, the emitter is over there at near that big tree. We are at least 60 meters, but I will measure it and make sure how far are we still detecting the signal. I was really surprised to see how far we can catch NFC radio emissions with a simple AM receiver. The signal from the dongle was still detectable after 100 meters in the radio scanner, if you're in the right direction, because the signal seems to be highly directional. After showing that it's possible and practical to use the NFC radio on a smartphone to exfiltrate data, this research demonstrates that it's also practical to use an NFC dongle to bridge the air gap and exfiltrate data via an out-of-band NFC radio emission. Basic tests included a 10-meter transmission through 2 rooms and 2 concrete walls. This is very early research, with almost off-the-shelf components and simple transmission techniques. It should be assumed that with more research on this topic and dedicated hardware, a greater range and data rate are possible. So the conclusion here is that on an NFC-enabled device that can be abused, it's possible to effectively implement an out-of-band, long-range exfiltration channel.